Okay, let's look at some examples from the text. Let's look at these three examples, 4a, number 1, 4b, number 1, and 4c, number 2 and 3. We'll just look at these parts of them. Okay, the first one is 4a, number 1, which I could display in the book, looks like this, and it talks about two teachers, Mrs. Urquiza, and Mr. Genzer, both teaching mathematics, and they talk about 4 students, and we have set A and we have set B, and it says decide whether the relationships that they mentioned in the second part are functions or not. And this is probably easier to look at if you just look at it in terms of a mapping. So let's look at them written out over this way. I've left the circles off here, but we have Mrs. Urquiza here and Mr. Genzer here, and they're their students. They mentioned that the set of students was set A, so let's just call that one A. And the set of teachers was set B, so we'll call this one B. And then the first part of the number 1 says, look at the relationship between the first set A and the second set B. X is in Y's mathematics class. Okay, so that means we're starting with these and going over here. So Mike is in Mrs. U's mathematics class, Lucy's in Mrs. U's, Lydia's in Mr. G's, and Diana's in Mr. G's. So this is the mapping, this is the relationship, this is the relation. It is not, this is a function, because each element is mapped to only one thing here. Each student is only in one of these teachers' math classes. Okay? So that one's a function. Okay. Now, we erase those arrows, and we'll get the other function. So let me get that one erased. The other relation, it might not be a function. Turns out it isn't. Let's redo the circle here and do this one here. Part B says the relationship between the first set is B and the second set is A, is X is Y's mathematics teacher. So Mrs. U is Mike's teacher, and she's also Lucy's teacher. Mr. G is Lydia's teacher, and Mr. G is also Diana's teacher. This relation is not a function. It's the inverse of the other relation. The only thing I did is I changed the directions of the arrows, but these have an element in the domain here is mapped to more than one element in the range. This element has 2 images, so that's not a function. So that's the definition, that shows the violation of the definition of a function. Now, if we go on, we're going to look in 4b at number 1. Let me go ahead and bring the book up to that point, and we'll look at that together. Here's 4b, number 1. And there's several different diagrams there. We're going to look at B and D, and we're supposed to copy and complete the table, then put a little X in one side if there's not enough information to make one, and then and let's finish it out in the other ones. Now I've copied them over here, so we don't have to waste any time with that. Let's finish the table first. Okay, X squared plus 1. So this is going to be negative 3 squared plus 1, that's 9 plus 1 is 10. 0 squared 0 plus 1 is 1. 2 squared is 4 plus 1 is 5. 1/4 squared is 1/16. And 1 is 16/16, so that's 17/16 there. Now here we have a 5, and we want to know what goes into it. Now I already have one of them over here, so there is another possibility. You could have a negative 2 squared and make that equal to 4, and then add 1. But now here's another 5. Is there anything else I can make that with? Well, no. It turns out there isn't any other number whose square is equal to 4, and so there's no other number I could add to 1 to make 5. Okay. Now, after we filled in the table, then they ask you to figure out what's the domain. Okay. Well, in this case, if I look at this, if I look at the domain is all these numbers here, but they mean the domain of this function. And so they mean all the things you can put in here that even have an image. So in fact, this is the answer to number 1 is the table. In number 2, the answer is the domain. Well, it's all real numbers, okay? Any real number can be put into that function. Then it asks for what is, whether 0 is in the range or not. Is 0 in the range or not? Well, think of that. If I had 0 here, then I'd have x squared equals negative 1, but that can't happen, so no. There is no point at which y is equal to 0. Now let's look at the other one down here. We've got the square root of x function. We're going to put negative 3 in for x. Well, no. If I put negative 3 in for x, it's undefined, so maybe put a little cross symbol there. There is no function there. or functional value. -3 is not in the domain. If I put 0 in and take the square root, yeah, that's okay, square root is 0. If I put a 4th in and take the square root, that's okay, square root's a half. If the square root is 1, well, the number must have been 1, so that's okay. If I put 9 in for x, I get 3 as the square root. And now, if I'm getting something out that's 10, what did I put in? Well, I put in something whose square root is 10, namely 100. So now my table's complete. Now let's look at the part 2. What's the domain? The domain's all the allowable x's, and we saw there are some that are not allowed. So in fact, the domain is the set of all values that are greater than or equal to 0. And you could say all real numbers, but it's implied if you don't add that. So all the numbers greater than or equal to 0 in the domain. Now, the next one it says is 0 in the range? Well, yes, we have that point right here. So, yes. Okay, let's stop here and then we'll do the next problem on the next video.